Hello, welcome back. Today we are doing Trig to find a side. On page 92. Oh, excuse me. 93 for me. So today our goal is to use trig to determine a side length. We need red and blue for our colors today. Make sure I have both of those. And we should be good to go. All right, so this is your first glimpse into what trigonometry is. And trigonometry is pretty sweet. Okay, there's a few little vocabulary words that we need to know. The first one, people always tell me that it sounds like I'm saying the type of cheese, but I'm not saying cheese. I am saying theta with a TH, not an F. This symbol tells us that we're looking for an unknown angle. Okay, like when we use X for an unknown value, we use theta for an unknown angle. So if I have a right triangle, I might use theta to mark an angle. And that angle that's being marked, that's called the reference angle. Okay, and the reference angle we use to name sides. Okay. And last but not least, and I'm going to talk about this more in a minute, we are studying trigonometry. And that literally just means the measures of triangles. Metry means measured, trigo means triangle. So what trigonometry does is it relates the angles to the sides and tells us that based on the angle, we could probably figure out what these other sides are. Okay? So here's the really important key for today. Okay, this is the really important stuff for today. Okay, if I were to draw a triangle, I need to know how to label the sides based on the reference angle. So let's say the reference angle is this angle here, and the reference angle can only ever be the two acute angles in a right triangle. Okay? The one side we already know is the hypotenuse. The hypotenuse is always the hypotenuse no matter what. But these other two sides are going to get names that are more specific than just leg. We're going to call the side that it's next to the angle that makes up part of this angle down here, we're going to call this the adjacent side. And adjacent just means next to. And we're going to call the side that's furthest away from the angle, that's not actually touching, making the angle, we're going to call that the opposite side. Okay? So we determine where the adjacent and the opposite sides are based on where the reference angle is, where theta is. Okay, so if I were to draw this triangle, and put the reference angle up here, the hypotenuse stays in the same place, but the adjacent and the opposite sides are going to switch because now this side right here is next to my reference angle. And now this side is across from it. And I can even turn the triangle in another way. Say that angle right there is my reference angle, and I'm using theta to denote both the reference angle and an unknown angle. The hypotenuse is still across from the right angle. God, I spelled that wrong. Hypotenuse. Okay? And the adjacent side is still the side that's touching, that's right next to that angle. And the opposite side, that's the one that's across from the angle. So how I label the legs, whether adjacent or opposite, is based on where they are in relation to the angle that I'm using or I'm looking for. Okay? So why does this matter? Well, this matters because the three of the most important words in math are these three words: sine, cosine, and tangent. Okay? And sine, we abbreviate as SIN. And the sine of an angle, so this ends up being some number. So the sine of some degree measure, so this is a number that's determined, the sine of theta. So if I take the angle and I plug it into sine, I get a ratio. And that ratio is determined by the opposite side over the hypotenuse. Cosine, I abbreviate as cos, but I still say cosine. If I take an angle and I take its cosine, that is determined by the ratio of the adjacent side divided by the hypotenuse. And the last one is tangent. And if I take the tangent of theta, if I take some degree measure and I take its tangent, that is a ratio determined by the opposite side over the adjacent side. So what this means is that if I had some triangle, let's do one of the triangles that we know, one of those special right triangles. Okay, let's say 30 is my reference angle. I'll mark that as my reference angle. Okay, so let's say I've got one of these special right triangles. Okay, 30, 60, 90. I know across from 30 is 1, across from 60 is radical 3, and across from 90 is 2. So here's how this kind of all ties together. If I were to find the sine of 30 degrees, that would be opposite over hypotenuse. The sine of 30 degrees is 1 over 2. If I were to find the cosine of 30 degrees, that's adjacent over hypotenuse. So the cosine of 30 degrees is radical 3 over 2. And if I were to find the tangent of 30 degrees, That's opposite over adjacent. So the opposite side from 30 is 1. The adjacent side is radical 3. And again, if I just rationalize that, I get radical 3 over 3. Okay? And so how did I pick out these numbers to be this? Well, I know that this is the 30-degree angle. This must be the hypotenuse. The adjacent side is next to the 30-degree angle. And the opposite side is 1. So that's how I plugged in all these numbers over here. If 30 is my reference angle. Now all of this changes if I'm using 60 as my reference angle. Okay? So we're going to start to look at these ratios, because what's going to happen is we're going to be able to work backwards. We're going to be able to figure out the sides and then work backwards to find the angle. And our calculator is actually going to help us out with that. So let's do one more. Let's say I had a 3, 4, 5 right triangle. And this is my reference angle, so I'm going to go ahead and label my sides. The hypotenuse is always across from the right angle. The opposite side is 3. The adjacent side is next to the that reference angle. Let's say I wanted to find the sine of theta. Well, sine of theta is always opposite over hypotenuse. So the sine of theta in this problem would be 3 over 5. The cosine of theta is adjacent over hypotenuse. It's always this ratio. So the cosine of theta is 4 over 5. And last but not least, the tangent of theta is always opposite over adjacent. So the tangent of theta is 3 over 4. Okay? And we're going to talk more about this tomorrow in class. We'll do a couple of example problems, but that's where I'm going to leave it for today. So you need to be able to label the sides, and you need to be able to remember what sine, cosine, and tangent are, and be able to plug in. If you're having trouble remembering sine, cosine, tangent, you can remember SO, CA, TOA, or some old horse caught another horse taking oats away. Some old horse caught another horse taking oats away. And that's it for tonight.